The following program was produced by an independent community producer. The opinions expressed do not necessarily reflect those of the QATV staff or board of directors. QATV, in compliance with FCC regulations, is prohibited from exercising control over the content of independent, member-produced public access programming.
Hi, I'm Kathy Hogan. This is Dave Jacobs. And this is Gateway to Science, Sports and Games. And this is an instructional video that we have designed for the South Shore Science Festival. And it's the part that I'm involved with is, as I said, Gateway to Science, Sports and Games. And it also gets into the science of sound and the science of light and science and stories. These are activities that we do at the Science Festival, and what we're going to do is show you how to use them. We're going to tell you first what the principles are that you're going to learn through these items, and then we'll demonstrate them later. In this group of objects, we have a jump rope, some footballs, a globe of the earth, a hula hoop, and I am sitting in a swivel chair. What do they all have in common? We'll find out later. So in this first group, you're going to learn about the axis of rotation, not just of the Earth, but through games. Torque, centripetal force, angular momentum, and friction, or otherwise known as drag.
Over here we have a broomstick, a tube of toothpaste, a spreader, and a Flyswatter.
Which has not been used.
Which has not been used. And what do these items do?
Okay.
Over here in the second group, we're going to learn about the concept of the center of mass and the center of gravity.
So, we told you about the axis of rotation, the invisible line that the Earth revolves around. Well, you become an axis of rotation when you are using a hula hoop. You in the middle. And the axis goes this way in a vertical line. The movement, the motion is going this way in a horizontal line. Okay, now do you want to tell them about the opposite of that and the jump rope?
Yeah, so
Okay.
with the jump rope, kind of a similar thing, but different in a way.
Yeah, same principles, but
same
different
principle.
applications.
Let's untangle it, maybe. If I'm lucky, I'll create a knot here, and it'll be your unsalvageable jump rope. All right, so when you use a jump rope, oh, what do you know? We got a knot, of course. Gee, wizard. There we go. So when you use a jump rope, your axis of rotation, and correct me if I'm wrong with this, Kathy, is right here.
Yeah, it's
So
going this,
and so
going that
this
way.
becomes the imaginary line straight across, and then the actual rotation is going over your head, down around your your abdomen area, under your stomach, around your backside, and then back up over your head. But your axis is that spot in the middle, that straight line.
And that's going on a horizontal
Yep,
straight
on the horizontal.
line,
So
right?
it's a horizontal axis rather than
Right.
when the Earth is a vertical
Right.
axis, where the Earth spins in a horizontal fashion.
Right. And then the motion of the jump rope goes in a vertical
Yes,
plane.
vertical plane.
Okay.
Yes.
I bet you never thought you could learn this kind of science through your games. Games are a great way to learn about science because you understand it instinctively. And this way you're learning the language of it. So let's see. Let's move on next to the broomstick, Flyswatter, Did we finish this?
And then we're going to do the football.
Oh my goodness!
So the football.
Oh, you want to demonstrate this?
Yes,
I
the
know.
football here. Maybe just put that down.
Yes.
The football here, this angle of axis is from here to here, and it revolves or it spins at this point. If you were to speed this up to a faster speed, and we can't do it here because of the limited space, but it actually, and you've probably seen it maybe on TV, or maybe you've even experienced it. It sometimes happens when you're playing football for any of those boys and girls out there that play football with their friends. As it spins, it'll actually increase in speed and will turn and rotate at this point and along the taller.
Yeah, it's a long axis of rotation now.
Yeah. And then as it slows down, it will fall back down to this point. So.
And you can challenge your friends to do this. You know, see who can do it the best.
Yeah, that's what we were doing yesterday.
Yeah, right. You did it much better than I did. Okay, so now moving along to the broomstick, the fly swatter, the frosting spreader, and the tube of toothpaste. My goodness. All right, so what you want to do is ask somebody, now look at this broom. Tell me where you think the center of this broom is.
Right here. This
Right
is the
there.
middle.
That's the middle.
I
Yep.
know it. I know it's the middle.
Okay. Now, the center of this broom may not be the same place as the center of its mass. Now, what is the mass? I just call mass stuff. Everything is made of stuff. The scientific word is mass. Just like when something is very big, we say it's massive. It's got a lot of stuff in it. Or someone who's rich has amassed a fortune. They've got a lot of stuff called money. So, where is the center of mass in this broom? Is it here? No. Is that the center of gravity?
The center of
also
mass
called
is
the
not
center.
always in the middle.
It's not always in the middle. It's also referred to as the center of gravity. As I understand it, I think they're interchangeable.
Okay.
Pretty interchangeable. Yeah. Let's see, it's still tipping. I've got quite a ways to go. Ah, that's almost there. Sometimes I kind of cheat and do it at an angle with my finger.
Ah. Use your elbow there.
Yeah, it's pretty much there.
Awesome.
So that's about the center of mass
Yeah.
of this broomstick. But it's quite a distance from the actual center of the broomstick.
And we have these different items up here because, all items have, a center of mass, and they're all in different places. This is an example of a spreader. Even a lot of people like to think it's right here, but in this case, it's actually going to be over
It's going to fall.
a little bit more.
Right,
Just a
on the
little
handle.
more, yeah.
Onto
Your
the
spoon,
handle.
if we had a spoon here,
Right.
usually is around the neck before you get to the ladle on the spoon, because there's about as much mass in the ladle part
Ladle.
with the actual spoon as there is in the part of the spoon that you actually hold. So
You do a very good job of
yes,
that.
I know. I should just do this. This is what I should do. So, but everything has it. This is the middle of the toothpaste, but obviously not
Obviously
the center
not.
of
If
gravity.
it falls, gravity takes over.
But you can see it is right here. So there's about an equal amount of mass on this right-hand side here as there is on this left-hand side
Right.
over here. So very good. And the same thing with the fly swatter as well. Went to find it, but it's right about there.
Good.
And I wonder myself, is it the same? And it would be, if you flip it over, it should be the same on the other side.
Could be different from the design, the way it
Yeah.
goes in the air, yeah.
But yeah.
So these are the challenges that you can do with your friends. See who can do it the best, see who can figure out the center, and the center of the object, and then find the center of mass. And they're not always the same place. Sometimes they are. Sometimes they are the same place.